Good afternoon, everyone. Today we're going to start our discussion on doing ARIMA model, which stands for Autoregressive Integrated Moving Average. Now, I shared with you some references. I encourage you to go here to this sites. This is online stat of Pennsylvania State University. So it gives us a good introduction, a good lesson about ARIMA, the ARIMA process. And also this one, how to write the AR equation with seasonality differencing. And then this is coming from Stack Overflow. And then also these are excellent resources. So I leave you guys to peruse over this. So we're going to make use of these packages. Okay. Naglo-load pa siya. Ito minsan disadvantage ng masyadong maraming packages at the same time. Pero pag once they're loaded, so okay na naman siya, no? Anyway, I also share this class kasi this is one way to install the TSM package. So you can try this, but you'll have to first install. So pwede yung ipacman underscore payload si remotes package. Okay. And then from remotes package, we make use of install.github. Okay, so you try, kasi iba kanina, they were still not able to load it. But for the others, they were able to. So if you are not able to load a particular package, what you do is Google it class, and then try to see the source of the package. Sometimes packages are not installed because it's not archived in CRAN. So it's still with the author of the package. So you'll have to find out saan yung author, no? Okay. All right. So we have discussed this before, time series analysis, but we haven't discussed itong si Control C. Let me share this in the chat box. Okay. So there are many ways to model time series. You have exponential smoothing, you have different types, maraming klase modeling for time series. One of the most popular, one of the easiest, and one of the most robust one is the Box and Jenkins approach. So I will just leave you class to search the history of this approach in Box Jenkins. These are two people. So they developed this method called ARIMA, which I said stands for Autoregressive Integrated Moving Average. So let's first decompose what ARIMA stands for. The AR there stands for autoregressive. Okay, so very what's the term for that? Very suggestive, no? Suggestive. Yung name na AR. Hindi lang. No, kung ano dito. Ito class, yung AR na to. Very suggestive siya. Auto-regressive. Auto means self, no? Regressive has something to do with regression. So when you're using the past values of your time series itself to explain the time series, then you're using autoregression. So let's have an example. Suppose I have a time series. Kunyari, ang mga values ko 10, 8, 7, say, then 9, sorry, 8, and then 8 again, and then 10, then 11. Let me cut it there, class. This is the earliest, and this is the latest. So this is our time series, and we would like to model this. So this is your X sub t. Okay. Sub t means it's time series. No? Now, if you're going to model this, okay, and then you're going to use the past values of this data, this time series, then you're actually doing an AR process, autoregressive. So for example, Ano to positive yan hindi negative. So, I'm going to get the log 1. No? Ibig sabihin ng log 1 class, yung prior value ni 10, ni 11 is 10. Diba? So 10, and then here will be 8. Okay, ano yung previous value ni 8? 8 din. So you're just getting the log 1 value. So this is 9, this is 7, this is 8, and this is 10. Okay, of course, this series now will have one less, no? One less. Kasi wala tayong value dito sa, we don't have any previous value. Okay, so this is what we call x t minus 1. Okay, log 1 siya class. We can actually generate also log 2, x t minus 2. So, how is x t minus 2? X t minus 2 will simply be, it will be 2 logs nito. So yung 11, log 1, log 2, 8. Or it's the log 1 of the log 1, di ba? Log 1 ng log 1. Ito log 1 class. So ang log 1 niya is 8. If you notice 11 tapos 8, di ba? 10 tapos 8. So you just get the log of the log 1 series. 8, 8, 9, 7, 8, and then 10. So mababawasan na naman siya ng ng isa pa. Okay. All right. So this is your original time series. Okay. And when you're doing autoregressive process, you are using its past value. So just like this one class. This is order 1 kasi class. You're using its log 1 past value. So in effect, you're going to regress itong time series natin using its past value. Order 1 to. Pag order 2 class, you have both log 1 and log 2. So ngayon, ito gagamitin natin. So it's like regression class. Ito yung dependent variable natin. Ito yung independent variable 1. Ito yung independent variable 2. Your independent variable 1, variable 1 is your log 1 ng time series natin. Itong independent variable 2 is the log 2. Okay, so you're now going to express your x sub t as a function of your is equal to whatever that equation is. It's a function of x sub t minus 1, here, x sub t minus 1 and x sub t minus 2. Para ito yung mga predictors natin, class. So that's your AR process. Okay, paki-chat please kung naintindihan yung what the AR process is all about. Okay, thank you. Okay, so sana clear, no? Clear ko na to. Okay, thank you for your response. Now, MA class, MA, moving average. Si moving average class, similar din siya kay autoregressive. The only difference is that you're not using the past error terms. Rather, you're not using the past values of the time series, but you're using the past error terms. Okay? So I'm going to explain this in a while, no? Pero ganun din siya, no? Your x sub t is equal to a certain function where you have your residuals, no? Errors. Kunyari, past log 1 ng error. So epsilon sub t minus 1. Okay? So it's a function of your error term at t minus 1 and then error term at time t. Now, so yung error term dito class, it's not the error of your regression model, hindi yun. Iba yung error term dito, no? So we'll explain this as we go along. And then lastly class, integrated. Kaya nga, ARIMA siya, no? So it's a combination of AR and your MA process. I stands for integrated. And what happens with I? You differentiate. You're differencing your data with the purpose of converting it to a stationary time series. So I'll explain this in a while. So, balik tayo dun sa example. Sana pala hindi ko kagad in-erase, no? Okay. Oops. Balik tayo dun sa example natin. Okay, what do we mean by difference class, no? What do we mean by integrated, which is to difference your data? So, for example, again, example lang, say 10, and then 8, 7, and then 8, then 9, and then 10 again, and then 12. So let's suppose this is your time series. Okay. Now, in an integrated model, okay, yung ID to class, we're not now modeling the original time series. Ang mangyayari class, you're going to get the difference. So for example, this one, 12 minus 10, that's 2. 10 minus 9, that's 1. 9 minus 8, that's 1. 8 minus 7, 1. 7 minus 8, negative 1. And then 8 minus 10, that's 2. Okay? So you now have class a series, okay, that was derived from the original na x sub t. Kaso, ang ginawa natin, dinifference natin. Ibig sabihin, the value at x sub t minus x sub t minus 1. Okay, so that's, this is now just like a difference ng x sub t. Isang differencing lang. Kasi pwedeng dalawang differencing, no? Magdi-difference ulit tayo. 2 minus 1 ulit, etc. Okay? So, in an ARIMA process class, what you're modeling is now the new time series. Okay? Now, why do we need to do this? Bakit kailangan natin gawin to? Eh, di ba, aren't we now modeling a different time series? This is the original series. This is what we need to model. So if ever you'll come up with a model that's based on this, then that's not the model already for the original time series, di ba? And if you're going to predict the values of this one, then you're not predicting the value of the time series that you're modeling class. Okay, so there will be adjustments later on when you're differencing, when you're integrating your time series. Okay, but there's an important reason for that class, and it's to convert the time series into a stationary. Okay, which we will now be discussing. Okay, let me again delete this first, and then let me go here. Okay, so let's first learn our models. Okay, so this is the LaTeX. This is the math formula for that. Share ko sa inyo class yung formula na to. Tapos share ko na rin tong pangalawa para ano. Let's see. Okay. Share ko na rin to, no? Para, and then I discuss. Okay, Control C. Para tuloy-tuloy yung discussion. Control V. Okay. Let's take a look at this class. So we're looking here at the AR1 process, no?
Sir, hindi po na-send yung AR1.
Sorry? Ito?
Opo, hindi po na-send.
Sorry. My bad. Hindi ko pa rin na-send. Okay, so nauna to class yung AR1. I'm sorry. Okay. All right, let's take a look at AR1 process class, no? I-load natin to. Okay. All right. So see here class the equation. So, actually class madali lang siya, no? Kasi sabi natin, di ba, autoregressive siya, no? You're using past values of itself. Take a look at this one class here. Yan. Ito yung kaninang series natin class, yung log 1. Diba? You generated a new series and it's the past one value. Diba? So if you recall class, diba, in-illustrate ko to. So you're now creating a model for your time series x sub t. and it's equal to, dali lang class may patukalan dito. Dali. Class, sandali Okay. So, diba, this looks like a linear regression model, diba? Ito yung regressor natin. Ang regressor natin yung yung log1 ng values ng time series. So this is just the intercept. I'm sure if you have done linear regression class, ito yun. Diba? Ito yung ano natin, simple linear regression to. Ito yung intercept, ito yung slope, at saka ito yung residual, ito yung error term. So practically, class, this is just a simple linear regression. You're regressing your your time series on its past value, log one lang. No? Okay. So this is p sub 0. This is your intercept. P sub 1. This is your slope. Okay, and this is your error term. Okay. Now, unlike regression class, kasi sa regression kahit anong value to, di ba? It can be hundreds. Walang restriction dito sa P sub 1. Sa time series class, hindi pa pwede. May restriction dyan. Okay, ano yung restriction dyan? So let's show this one class. Okay, wait, ito ba yung sinurk sa inyo? Hindi, class, mali ito So, mali yan class, ito yung tama, no? Maybe you can just delete this. Or, tanggalin nyo lang muna yung ano. I was trying to decipher this, hindi ko pa makuha. So, pasensya na. Kaya ginawa ko ito, no? Yung next one, ito. Okay, so let's show this class. Okay, and it gives us the characteristics of your AR1 process. So ito yung AR1 process natin, si x sub t is equal to a function of your x sub t minus 1. Okay, where P null is your constant or your intercept. P1 is your AR coefficient. Ibaba ko nga yan, sorry. Okay, ibaba ko siya. P0 is your constant. And then, let me put here, para next line siya. Yan. P1 is your coefficient ng AR natin. And then, ito class, no? Meron ako sinabi dito. Our theoretical mean is P sub O over 1 minus P sub 1. Okay, I'll explain theoretical mean in a while. And then, dapat class, yung P sub 1, ang condition yan, your P sub 1 cannot be greater than 1. Okay, absolute value of P sub 1. Which means that your P sub 1 can be negative, no? It can be positive. It can be negative, it can be positive. However, it cannot be less than -1, or it cannot be greater than +1. Kasi may absolute value dito, di ba? Ang ibig sabihin nitong absolute value nito, P sub 1 is, diba? How do you represent an absolute value? Ganito yan, no? Negative 1 dito. Okay? So P sub 1 is just between negative 1 and 1. It cannot be 1. Class, it cannot be 1. Why? If this is 1 class, so mawawala na to, no? Diba? This is just like P sub O plus X sub T minus 1. This becomes, okay? Ano nangyayari dito? This becomes a white noise class. Magiging white noise na yan. If Phi is 1. Okay? Now also, it cannot be more than less than negative 1, and it cannot be more than 1. Kasi kunyari, pag negative 1.2 yan, or positive 1.5, okay, lumampas sila sa negative 1 at saka 1 na bounds, then this becomes a random walk. Random walk na siya. Tapos itong may intercept dito, may constant dito, pag non-zero to class, it becomes a random walk with drift, no? Ganun lang yung class, no? So if phi sub 0 is 0 class, and then this phi sub 1 is greater than 1 or less than negative 1, then this becomes a random walk. Pag may value tong phi sub 0, it becomes a random walk with drift. Ibig sabihin yan, class, yung value niyan, ano yan, kung saan magme-meander yan, no? Kung saan pupunta. Okay? So, ang AR1 process class, ang condition yan, dapat yung phi sub 1 natin na value should be, the absolute value of it is less than 1. Okay? Which means, class, that the value of phi 1 should be between negative 1 and 1. So, pwedeng 0.5, pwedeng negative 0.9. Okay? Alright? Ngayon, kung 0 naman yan, so, wala na yung model nan. Kasi kung 0 yan, class, then you're actually not regressing it based on its past value, di ba? Okay, sorry, class, drinking water. Okay, questions, class? Kindly chat, please, kung okay, clear tayo so far sa AR1 natin. Okay, thank you. How about the others, class? Class, I apologize for having to cut once in a while. No? Okay, good. Now, isa pang explanation class ito, no? Ano ibig sabihin theoretical mean? Which is equal to P sub null divided by 1 minus P1. So may explanation akong linagay sa baba, class. So for our reference na. Okay. Oops. What is your theoretical mean? Okay. Importante ito, class, ha? Yung theoretical mean ng AR1 process, that's the long run average value. Okay. Long run siya, class, ha? Long run. Take note, long run average value. So this is that value which the process fluctuates around for the long term, no? Okay. This theoretical mean represents the expected value of the process over time. Okay, and then there's this assumption that assuming stationarity, explain natin kung ano stationarity. Now, this is different from the arithmetic mean. An arithmetic mean is simply, you just get the average, no, of the time series. Yun ang arithmetic mean. Okay? So, si arithmetic mean, class, involves summing up all the observed values. Alam nyo naman yan, class, di ba? Lahat ng values, i-divide by natin, i-sum up natin siya, tapos i-divide natin ang number of observations. That's your arithmetic mean. Okay? Or that's also called the empirical mean. Okay? So, yung empirical mean class, that's your arithmetic mean, okay, it can be affected by short-term fluctuations. Okay, so take note, yung empirical mean or yung arithmetic mean, naapektuhan niya ng lahat ng values kasama ng ano, yung mga short-term na fluctuations. Okay? And may not accurately represent the long-run behavior of the process. So si long run process, parang yan ang long run na average and it's not equal to the arithmetic mean. Okay? So we'll take a look at this more in greater detail once we as we continue discussing the AR and MA process. Okay? So sabi ko dito, while the empirical mean of a very long AR1 series might approach, pwede, no? Pwedeng yung empirical mean, mahabang-mahaba yung process natin. Pwede rin siyang maging almost equal to the theoretical mean. They are conceptually different, no? And are often not exactly the same, especially for shorter series or those with strong autocorrelation. Kung may iksi lang class yung shorter series, okay? Possible na na malayo talaga si theoretical mean kay kay arithmetic mean, no? O kay empirical mean. Okay, clear yung class? Clear? So, inano ko lang, dinescribe ko lang yung long run average kasi later on, i-discuss natin ang class when we go to multivariate time series. Clear so far, class? Theoretical mean, clear? Empirical versus empirical or arithmetic mean. Of course, alam nyo na yung arithmetic mean. Kukunin mo lang yung average nun. And as I said, si arithmetic mean, pwedeng maapektuhan niya ng short values, no? Short-term values. Si theoretical mean hindi, kasi yung pang long-term yan eh. So that's the long and short of it. So, sabi nga natin, pag malaki yung time series natin, pwedeng mag-converge yung theoretical mean at saka yung empirical mean. Pwedeng halos equal sila. However, pag short lang yung mga time series class, they're not the same. Okay, next class. Let's go to AR2. So kung alam natin yung AR1, alam nyo rin si AR2. Nabigay ko na ba to class? Have I given this AR2? Yes or no, class? No, okay, sige. So ganun din naman si AR2 class, no? Sama ko na itong characteristics, Control C. Okay. So let's take a look at the formula, which is just very easy, class. So ang formula ng AR2, nagkaroon lang tayo ng dalawang regressors, no? Yan, no? P1 x sub t minus 1 and P2 x sub t minus 2. You still have your constant here. Maybe we can make this as P underscore 0, okay, to be consistent. So, to model the time series, kailangan natin yung log 1, okay, and log 2. Yung kanina ginawa natin class, pinakita ko, no? So, you have now your x sub t minus 1 and x sub t minus 2. So, you have now a different slope for your phi1 and phi2 plus your error term. Okay, so as I mentioned here, so dapat ito, class, no? Phi sub null is a constant, phi1 and phi2 are parameters of the model, and epsilon sub t is white noise. Okay, and then let's take a look at the characteristics, class. Interesting din itong characteristic ni ni AR2. Meron ding mga conditions, no? So here, okay, gawin delta yung ginawa dito no? Pero okay lang yan, no? Whether it's delta, kasi may ginamit ko equation na delta mamaya dito eh. So whether you're using phi null or delta, it's the same. Anyway, it just represents your constant. So x sub t is delta plus phi1 x sub t minus 1 plus phi2 x sub t minus 2 plus your epsilon, your white noise. The theoretical mean, class, is this one, no? It's equal to the constant, okay, over kanina 1 minus phi1 lang eh. Ito 1 minus phi1 minus phi2. So this is your theoretical mean. This is the long run average. Okay? Long run average. And then what are the stationary conditions? Ibig sabihin nun, ano yung mga constraints ng values natin? Ito class din ninyo. P1 plus P2, pag inad natin siya class, hindi pa pwedeng greater than 1. So which means class that hindi pa pwedeng hindi pa pwedeng 0.9 plus 0.9. Hindi pa pwede yun kasi lalampas ng 1 yun. Hindi pa pwedeng si P1 natin 0.9, si P2 0.9 din. Okay? Hindi rin pa pwede yung difference sila is greater than 1. It should be less than 1. And same thing class, same thing as yung sa AR1, although ito yung P2, ito no? P2, negative 1. Ito yung P1 kanina natin sa ano, sa AR1 process. Okay? Or you can write this class as pareho lang equivalently. Absolute value of P2, ito yun, di ba? Is less than 1. Pareho lang yun. And the rest are the same. Okay, so ito yung mga conditions class ng AR2 process. Okay? So pag nakakita ka ng equation tapos yung P1, 0.9. Tapos yung P2, 0.8. So that means lumampas ng 1 yun. So hindi AR1 process yun. You're talking of a different process. But that's not an AR1 process. An AR1 process will always obey or follow these conditions. Okay? Ito, no? And they're called stationary conditions because later on I'll explain kung ano yung stationarity, tapos kung ano yung bakit kailangan natin gawing stationary yung ano natin, yung time series. Okay, pause again class, pause again for AR2, paki confirm class kung nakuha. Kung naintindihan yung AR2. Okay, good. Good. Ang laking tulong talaga class ng LaTeX, no? That's why I really love LaTeX mathematics kasi ang clear dito, no? Okay? Ang clear tapos very ano pa. So I would encourage you to really learn more about LaTeX, no? And I'm happy that here na-introduce kayo doon kahit paano. Hopefully in the future magamit nyo siya, no? All right, then let's go to an ARP process class. Pag sinabing P class, order P. Which means that P lags, no? Okay, inunin ko na itong ano, Control C hanggang MA1. In the interest of time, sabihin na natin to, Control D. Okay, let's go to the ARP process class. Well, the ARP process class is just, yeah. So this is your constant plus, okay, the sum of P orders of X sub T. So tinan nyo to class, yung equation natin, ito yung phi sub I and I ranges from 1 up to P. Ibig sabihin, sa substitute natin dito, 1 hanggang kung ano yung P. Kunyari, 3CP. No? Order 3 siya. So sa substitute natin, 1, 2, at saka 3. So tatlong P1, Pi yun. Tapos ito, ang partner niya, T minus I. Okay, notice, ang may sub I lang class, itong phi at saka yung X. Ha? Si epsilon sub T wala. Epsilon sub T lang talaga yan. Okay? So let's suppose it's, as I said, order 3. No? Pag order 3 yan, so ang magiging equation natin, class, it will be, so ito, class, di ba? Tapos yung 3 logs, ito, dito natin explode, no? So starting from 1 up to 3. So magiging ano yan, phi1, and then a phi2, and then a phi3. There. Tapos ito, x sub t minus 1. Okay? Ito yung log 1 na, ano natin, na time series. Ito yung x sub t minus 2. We illustrated this a while ago. Yung second log naman. Tapos ito, t minus 3. Pangatlong log to, no? Yun ang magiging regressor. And then you have here your constant, phi sub 0. So plus yan, plus plus, and then plus your white noise, your error term. Epsilon sub t. There you go, class. This is your ARP model. Okay, so depende dun sa order P. So if it's an AR10, so 10 P yan, class, no? But usually naman, class, hindi na umaabot sa ganyang klaseng yung mga model. Ang pinakamahaba nakita ko lang is AR5, no? Pero that's medyo extreme na yung ganong cases na Okay, class. So I hope clear yung AR process, no? Auto-regressive. Okay, so to summarize, class, auto-regressive, you're just using the past values of your time series. It depends sa lag, no? Lag 1 means you're going to get all the values 1 period before. Tapos pag lag 2 naman, 2 periods before. 2 periods before, tapos hanggang sa taas, no? Tapos 3 periods before, that's lag order 3. Okay, so that's your autoregressive process. Now let's go to the next one, which is your MA process, moving average process. Okay, this one, class. Si moving process, yan, tinan nyo. Halos pareho lang siya, class, ni AR process. The only difference is your regressor. Pero parehas din siya, class, it's like regression, so may constant din dito. Tapos may error term dito, yung white noise natin. Okay, so ito pareho dun sa di ba? Pareho dun sa AR1 process natin. Merong constant, tsaka merong error term, yung white noise. Tapos meron ditong regressor. Ito, instead of phi, ang ginagamit natin theta, no? And then this one is error. Okay, lag 1 ng error. Okay, I'll explain what this error mean. What does this error mean, It's not the same as yung error, yung residuals na isang regression model. Hindi yung kunyari nag-AR1 ka muna. Tapos 'di ba may may difference yung actual value at saka yung predicted value. Tapos if you subtract that, you'll have your residual, which is also, 'di ba? Yung epsilon sub t, yun yung klase, yung error dun sa sa AR process natin. Yung error dun, class, hindi yun yung error dito, It's a different error. Okay? So I'll explain that as we go along. Wag muna ngayon. Tapusin muna natin to. So, si MA process, class, may condition din yan. Si MA1. So as I said, itong mu is this is the constant or mean of the series. Okay, ito, class, yung theoretical mean. No? Theta 1 is the parameter and epsilon is white noise. So tingnan natin, class. I think I shared this with you, no? Did I share this with you, class? Na-share ko na ba to? Yes or no, please? O ito lang na-share ko. Up to here lang ba, class? Not yet. Okay, so share ko to. Kung hanggang saan umabot para Control C. Na lang. Okay, chat natin. Okay. So let's take a look, class. Aralin natin tong M1, MA1. Okay, ito yung condition siya, no? Okay, tingnan nyo, class. So here, MA1 process. If you equation natin x sub t is equal to mean plus epsilon sub t plus theta 1 epsilon sub t minus 1. So this is past error term siya, where mu is the process mean. Okay, so ito dito, class, sa MA natin, ito yung equivalent na mu sa class, naalala niyo dun sa AR1 process natin. Sa AR1 process natin, class, diba, the mean is equal to the intercept, the constant, okay, over 1 minus P1 for an AR1 process, no? Ito yung long run average. Sa MA process, class, ito na yon. You don't have to compute anything. Ito yan. This is now the process mean or the long run average. Okay? Epsilon sub t is your white noise. Okay? And the characteristic of the white noise is that its average mean is 0 and the variance is constant. Okay, and theta 1 is the MA coefficient. Okay, so going down, yaw. Hindi ako makaano. Yan, ayaw. So, clear ko muna ulit to. Close. Okay, let's take a look at the properties. Kailangan dito sa browser. So, dito sa scroll bar. Okay. All right. First, yung long run average, yung expected value ni x sub t is equal to mean. Ito yung mu. Yung nasa equation, ha? Kasi itong ibig sabihin to expected value of x sub t, this is your long run average, no? This is not your empirical mean, class. Hindi siya yung kinukuha nyo lang yung sum at saka divided by the number of observations, no? Yun yung arithmetic mean or empirical mean. This is the theoretical mean. Okay, so unlike the AR1 process, i-compute mo, di ba, yung long run average, which is equal to, as we said, mu is equal to the phi sub 0 or the constant divided by 1 minus phi 1. Tapos kung AR2 process pa, minus phi sub 2 pa. No? So, ganun yun. Okay, and then dito may formula class yung autocorrelation function, which we're going to discuss in the future. So, wag muna ngayon. Sa Friday na tong ACF function. Okay. And then ito class, take a look at this. May invertibility condition. Okay, so ganun din to class, no? Parang pareho lang ng na requirement ng phi sa AR. So dapat yung absolute value ng theta should be less than 1. Ibig sabihin hindi siya pwedeng lumampas ng hindi pa pwedeng smaller than negative 1, hindi pa pwedeng greater than positive 1. Okay, may isa pang gusto kong i-discuss dito class sa invertibility condition. So what does this mean, class? What does an invertibility condition mean? Okay, nabigay ko ba sa inyo to? Okay, so it means, class, that an MA process can be expressed also as an AR process. So invertible sila, class. Si AR, pwede mong gawing yan, may equivalent siya na MA process. Tapos si MA naman, may equivalent siya na AR process. That's what we mean by that, no? Invertibility. So I think I shared this with you, no? Assuming invertibility condition, which is this one, di ba, class? Yung absolute ng theta 1 should be 1, less than 1. Okay? We can represent yung MA process, yung MA1 process as an infinite AR process. Hindi ko pa na-paste to? Okay, sige, sorry. Okay, paste ko to, ha. Ano ko lang muna to. This one, na-paste ko na to, hindi pa. Ito, di ba na-paste ko na, class? This one? Yes, okay. Pero yung ilalim, okay, kasi natigil doon kasi naka-print siya. Okay, so tanggalin ko muna, class, yung mga print, ha, para makopy ko yung longer. Okay. So, yung invertibility tayo, no? So, we're talking about the tingnan natin kung hanggang sa abot ng Sana pumayag si Zoom. Ayaw. Anyway, sige. Itong ayaw ko kayo Itong ayaw ko kay Zoom, kaya minsan naisip ko mas maganda nilang ilagay sa text to, tapos yung text yun ang isi-share ko sa inyo. Okay. Hanggang dito lang, Control C. Hanggang MAQ, ha. Ayan, okay. Alright. So, balikan natin si MA1 process, class. Ano ba yung mga conditions sa MA1 process? Okay. Ito, no? Dito sa invertibility. Si invertibility, ang sinasabi dito natin, class, dapat assuming na yung theta natin should be, the absolute value of your theta should be less than 1. If these conditions are met, class, si theta less than 1 siya, then yung MA process can be expressed as an AR process. And what is that process, class? Ito yun siya. Notice, class, tinan nyo. X sub t is, ang coefficient natin sin theta, negative theta, sub j is equal to, look at this, class. X na, x sub t minus j. Okay? X sub t minus j. Ano ibig sabihin ng class? Yung theta natin, class, yung mga thetas natin, is multiplied are coefficients of your log time series. Di ba kasi mga thetas natin, ang ano yan, ang coefficient, ang ano yan, yung sa equation yan, epsilon yan di ba? Theta and the error terms. So this is telling us that si MA process, class, it can be expressed as thetas times your x sub t's. So invertible sila. Ganoon din kasi AR process. Si AR process can be expressed as your phi, yung phi naman sa class, no? Phi times your epsilons. Okay, parang nag-invert sila, class. So that's what we mean by an AR process is invertible to an MA process and vice versa. Ganun, class, no? So example dito, okay, tingnan nyo to, class, no? So here, this can be expressed as x sub t is equal to epsilon sub t minus theta, okay, theta, class, to the first power times x sub t minus 1 plus theta squared x sub t minus 2 plus theta cubed x sub t minus 2, etc. Okay, so you're now expressing your time series as a function of its log values, pero ang coefficients mo yung mga thetas, yung nakuha sa MA. Same thing, class, pagbalik rin natin to, gagawin natin phi to, phi, tapos epsilon sub t minus 1, that will be your AR process, no? So invertible sila. Okay. Okay, naulit lang to, sorry. Alright, naulit lang. Okay, so clear yung class, ha? Ang gusto ko lang i-mention yung invertibility condition. Okay, so you can express your AR process as an MA. Okay, infinite number of MA can be expressed as an infinite number of AR process, while AR process can be expressed as an infinite number of an MA process. Okay, we can show that siguro next time na lang yung hindi ko pa nalagay dito. I was thinking of putting it, kaso na I think I forgot. All right, now let's take a look at MA2. So MA2, alam naman natin yan, no? So MA2 would be yan lang, class, no? Theta 1, theta 2, epsilon t minus 1, epsilon t minus 2. So you have this, your long run average plus your white noise, okay, plus theta 1, epsilon t minus 1, theta 2, epsilon t minus 2. And then, naka-define naman dito. Alright, ano nga, class, paki-chat, no, kung isang oras. Kung okay tayo so far, class, as far as MA, the moving average order 2 is concerned. Okay, good, thank you. All right. Okay, so and okay. Lastly, class, si AR, class, AR, how do we designate it? AR order P, di ba? So ang standard ng class AR P. P yung ginagamit, no? Si MA naman, MA Q. Later on, class, pag tinignan natin, ARMA, kasi pwede combination AR and MA process, ARMA PQ, where P denotes your AR process and Q denotes your MA process. Okay, so this is the equation of MAQ. So you have the long run average, constant mean, And then your white noise plus your summation ng yung components ng past error terms. No? Okay, from 1 up to Q. So Q can be 3. Pag 3 yan, theta 1, epsilon sub t minus 1, plus theta 2, epsilon sub t minus 2, etc. Okay, so you know the drill. Okay, so let's continue class. Okay, how about this class? Paano tong combination ng AR at saka MA? Kasi we can have this. So take a look at this. Control C. Shut natin. Control V. Okay. So tinan nyo to class. So first you have this constant C. Okay, you can of course denote this by either phi sub 0 or delta. Doesn't matter really. Kasi constant naman yan. So let's just replace it by delta. Delta. There. Okay, delta plus phi sub 1 x sub t minus 1, phi sub 2 x sub t minus 2 plus epsilon sub t. So in effect, this is your AR component class, di ba? Parang ito yung AR component natin to. Yan, kasama tong epsilon sub t. Tapos, okay, and this one also. This is your MA. Theta 1, epsilon sub t minus 1. So parang kinumbine na yung epsilon ng AR at saka MA. Okay, so this is MA1 process. This is AR2 process. Kaya nga ARMA 2-1. Okay, combination ng autoregressive na order 2 at saka MA moving average na order 1, order 2-1. Okay, let me pause for a while class and seek your feedback. Yung susunod siguro kayo magsulat ng ano, no? Ng LaTeX para ma-practice nyo rin. Any questions, class? Clear so far? Okay, good. All right, so okay, dinify lang natin. Okay, so sige nga class, gawin nyo nga yung ARMA 2-2. In fact, hindi ko papakita yan kasi may ARMA 2-1 naman kayo. Gawin nyo yung ARMA 2-2 class. Isa lang dadagdagan nyo dyan. Kasi you have already ARMA 2-1 and then dadagdagan nyo lang ng isa, no? Para maging ARMA 2-2. And then when you're done class, paki-chat so that I know if I may proceed. Okay, done class? Paki-feedback pag tapos na. Waiting for your feedback, class. Arma 22. Tagal, class, tagal. Anyone ready? Ready na ba? Actually, dadagdagan nyo lang yung Arma 21 eh. Yeah. Okay, that's correct, Vin. Okay. So, iba, class. Alright. Class, I have to move on kasi inaabot natin yung 260 plus na kasi para mapareho tayo dun sa kabilang section. Okay, so Vin, you're correct. Thank you. So, dapat ganito, class, yung yung Arma 22 natin. It's the same as Arma 21, dinagdagalan natin, class, ng Theta 2. Kasi yung order ng natin ng MA dalawa na di ba? Yan, no? Okay? So phi1, phi2 for your AR process, theta 1, theta 2 for your MA process. So that's how that should have been written. Okay? So ito, class. I hope kumaya. Yan. Okay. Class, in case na hindi tayo umabot dun sa dun sa inabot ng first section. Tingnan niyo yung last portion ng video ng ng kabilang section kasi dapat umabot tayo dun eh. Or ganito na lang, no? You may, of course, as usual, you may go. I'll just continue explaining para pareho lang ng kabilang session para pareho dun sa video. Alright, so Arma PQ class, ganun lang din to, no? General lang, no? So, there. Yes. P, order P ni AR process. Okay? And order Q ni MA process. Sinasum up lang. So, if this is Arma 2, 3, so magiging ang P natin 3, ang Q natin, kaya Arma 3, 1. Ang AR process ang AR natin 3, ang MA process natin 1. So magiging tatlong phi to, phi1, phi2, phi3. Ito naman isang theta lang, theta 1 lang. And notice, class, magkaiba I at saka J, no? Hindi pwede parehong I at saka I. I is equal to 1 to P and J is equal to 1 to Q. So yung theta natin dito, J, tapos yung epsilon natin, T minus J. Pero meron ka pa rin ditong epsilon sub T. Kaya meron tayo dito yung constant na we can replace by delta. Okay? There. Okay, so itong Sarima class, ano to? Okay, take a look at this class. Sarima class is seasonal, autoregressive. So ibig sabihin, may correlation yung kunyari every quarter, yung every 4th month, may correlation sila. Or every 12th month kung ano to, no, kung monthly class, no? So kunyari every July correlated sila. So that could yield to what we call a Sarima model. Okay? In fact, ganito to, no? May ganito pa yan, no? Ganyan. Dalawa siya class, no? Dalawa. Ito yung regular Arima component. Ito yung seasonal component. Kasi yung seasonal component, pwedeng AR o MA din yun, eh, no? Okay, and how is this written, class? So I would that you, okay, itong backshift operator, class, it simply means, okay, ito B1, class, ibig sabihin x sub t minus 1 to. Okay, ito B sub S, this is your x sub t minus S. Okay, so this is B1, class. It means that, as I said, backshift operator, maglalag tayo ng 1, magbaback tayo ng 1. Okay? Alright, so I want you to explore, for example, kasi ito sa Rima, no? I want you to explore how do you write? Okay, my question is how to write, let's say ARMA, let's say 2-2 process as in terms of backshift operators. Okay. So yung pagsulat, class, ng ARMA model, two ways. Yung isa kanina, ito yung ARMA natin, di ba? Right? Ito yung equation natin kanina. You can write that also in terms of backshift. Kasi ito mga log to, di ba? Order 2 to, ibig sabihin x sub t minus 1 at saka x sub t minus 2. Ito din, epsilon sub t minus 1, epsilon sub t minus 2. So, we can use this, class, yung backshift operator na to. Okay, tingnan ito. Phi1 times B. This is actually, class, your Phi1 times y sub t, x sub t minus 1. Ito yun. Ito din, class, yung theta 1 times epsilon sub t minus 1. So yung ARMA process natin kanina can be expressed as in terms of backshift operators. So sometimes, class, mas madaling isulat, class, kung backshift operator. Sige nga, I'll give you a few seconds. I-chat nyo nga dito, class, i-research nyo kung how to write, let's say kahit yan, ARMA 2-2 process as backshift operator. Sige, I'll wait for you to explore. Google nyo, class. Kung mas simple, class, 1-1 na muna. Yung 1-1, andyan na, class, eh. It's already there. No, class, come on. Class, ano? Anyone, please? Oh, magta-time na, class. Wala na. Time na. Explore nyo na lang, class, no? That should have been easily found. Okay, klase nyo to if you distribute this x sub t, no? Phi sub 1 times b x sub t. B here is B1, no? Kasi wala naman sa exponent. Yung B dito class B1 yan. Ibig sabihin, magbaback ka, maglalag ka ng isa. So B times x sub t is actually x sub t minus 1. Okay, so papakita ko na nga tapos just to prove to you that this is just the same. So distribute mo to x sub t minus this one class phi1 times bx sub t. So that's phi1 times x sub t minus 1. Kasi back shift operator na x sub t, that's x sub t minus 1. Okay. Kung dalawang log order 2 class, b squared dapat to. So this is equal to, and again class distribute epsilon sub t, okay, and then plus theta 1, back shift operator ni epsilon sub t is epsilon sub t minus 1. Okay. Tapos class, ano mo to? I-transpose. So this is just your phi1 x sub t minus 1 plus epsilon sub t plus theta 1 epsilon sub t minus 1. So this is another way to write your ARMA, okay, ARMA 1, 1, using the backshift operator. All right, so the time na pala. Kaya ang layo na hindi natin naabot, class. Okay. Okay, ganito na lang, class, no? Ang layo. Mabot kami ng 300 kanina. Mabot kami hanggang 300 ano. Okay. So anyway, I'll post the link dun sa ano, no? Sa YouTube ng kabilang section. Kung pwede class, panoodin yung last part nun. And then I'll just share yung mga shinare ko sa kanila. Yung mga shinare ko na ano na ito diniscuss kasi namin to yung differencing class, very important, no? Differencing. Okay? So with that class, I stop recording now.